right, so now you should be able to see what I'm writing. Okay, December 8th. Okay, and it's section 8-4. And basically, we've been dealing with these quadratics, okay? And last week we were literally looking at, ax squared plus bx plus c, just in standard form. We solved them, we graphed them, we kind of looked at the x and y intercepts, that sort of thing. All right, so this time we're going to be solving equations in quadratic form. Okay, so the equation is going to be in quadratic form. All right, and to do that, then we're going to want to solve it like a quadratic. So we're going to set it up with a u substitution type thing. All right, now first of all, let's take a look at this quadratic form idea. All right, so let's go back and look at like ax squared plus bx plus c. Let's just take a look at that. I know that's not an equation. I could set it equal to 0, and then we'll have an equation we could solve. All right, now something that we never, you just kind of get so used to seeing that, and you have two binomials, you FOIL it out, and you get this. All right, and you don't really realize we call it a quadratic, but I don't think anybody really tells you why it's quadratic or that it's in quadratic form. But every time when we have a quadratic like this, all right, granted, we can leave this b term out, or we could leave the c out, and it's still going to be a quadratic because you got the x squared in there. Okay, but if I've got three terms like this, and on this first one, that's got an x to the second power. This middle term has an x to the first power. All right, so if I've got three terms like this, all right, and my first one has an exponent of 2, and my second one has an exponent of 1, or in other words, this exponent is half of the first exponent, I'm in quadratic form. All right, so this relationship here between those exponents is what we're going to look at. So if, in other words, if I had x to the fourth, and this was an x squared, that would be half. So it would be in quadratic form. All right, and really, I could even have fractional exponents. We've dealt with fractional exponents before. So I could have an x here, and I could have an x to the 1/2 power here. That's half. All right, so then it's going to be in quadratic form. All right, now some of these, we kind of even did some of these when we just plain factored. If you remember, we did u substitution when we factored, and we did this quadratic form, and this was to the 4th power, and this was to the 2nd power. All right, well, if we're now solving, we're just adding one more step, right? We're doing that, the product rule principle, when we set the two products, then we set them equal to 0 and solve. So we're just adding one extra step from what we've done earlier in the semester. All right, so we are going to use u substitution method. And like I said, some of them, just like you could do back then, you might be able to do some of them in your head, all right, without the u substitution, but there's going to be others that's the u substitution is going to be very, very handy. All right, so we'll start out with a kind of a straightforward one here. Okay, let's suppose we've got like an x to the 4th minus an 8x squared minus a 9 equals 0. Okay, so the first thing I want to do there is look at those exponents. All right, so there's my x to the 4th, there's an x to the 2nd, so it is half. All right, so yes, I am in quadratic form. All right, now if you remember when we did u substitution earlier, we said, okay, well, whatever the middle term was is what we were going to let u be. Okay, so we're going to let u be x squared. All right, and then what we did was we kept the coefficients. So that has a coefficient 1, that has a coefficient -8, and then there's your -9. Okay, we're going to keep that. Here we will substitute u, and then for here we will have a u squared. So we always end up with that quadratic. Shoot, I wrote an x. I don't know why I wrote an x. So we'll have the u squared, and then minus the 8u, and then -9 equals 0. So we're just trying to get this down into a quadratic that's got a leading coefficient of 1. We got an x squared term and an x term. Okay, and if you remember, I had done this before of why and how. Okay, x, if u is x squared, That's my u, and I'm squaring that, then that gives us that x to the fourth. So that's why this is a u squared term. And we had talked about that in detail earlier in the semester. Okay, let me add that person to our list. Okay, all right, and then this is just going to be a straight factor at this point. So I got a u and a u. Let's see, you can guess and check this one. What we're going to have a 9 and a 1. I need a -8. We're factoring, so that 9's got to be negative. That's got to be a +1. And then we set each one of them equal to 0. So this one's going to be u equals -1. This one's going to be u equals 9. All right. And then I would say the number one problem here that people forget is they stop at that point because, you know, they've got a u equals and it feels like the right answer. This original problem was in terms of x. Our answers have to be in terms of x. So then this is where you go through and you've got to replace your u with your x squared. So we need to put our x squareds back in so that we've got something in terms of x here. So I'm going to replace that u with x squared. So I'm going to have an x squared equals a -1. I'm going to do it over here as well. I'm going to replace that u with the x squared and set that equal to 9. Okay, and then now I have some more work to do. When I take square root of both sides here, x is equal to plus or minus the square root of a -1. All right, well, now we can do this, right? Because we talked about that square root of -1 being an I. So x is equal to plus or minus an I right there. This one, when I take square root of both sides, I'll have x is equal to plus or minus 3 because square root of 9 is 3. All right, now, how many answers do I have? I have a total of 4, okay? I have 4 solutions to this equation. So there's plus or minus I, so there's 2. There's plus or minus 3, there's 2. All right, now you can see that or realize that. Like I could have looked at the very beginning and looked right here. This is an x to the 4th power, which tells me I'm going to have 4 solutions. Now, they're not necessarily all going to be real solutions. And if we actually take a look at the graph, if we were to put this in our graphing calculator, x to the 4th minus 8x squared minus 9, all right, what's going to happen? I'll give you a little rough sketch here, okay? If we were to put that original, this original thing in for y1 and then graph it and look at it, all right, well, we know we've got solutions of plus or minus 3, so we know it's going to go through there. And we know it's going to go through there. All right. And what happens? All right. Rough sketch here of what this is going to look like roughly without actually having a graphing calculator. All right. It's going to look something like that. Okay. And we've talked about this in the past. Where the curve crosses the x-axis are the solutions or the real solutions. So here's the 2 real solutions that come from this part right here. All right. These are your real solutions. All right. But because this is an x to the 4th, I really do have 4 solutions. It's just 2 of them are imaginary, okay? And when I have those imaginary ones, I don't see them on the graph. And we've talked about that before. We did the quadratic, and it either crosses in 2 places. It crosses at one place when the vertex is on that x-axis, or it's above it, and it's an upright parabola, so it doesn't cross at all, and then those are imaginary solutions. Okay, so just another, you know, way to emphasize or look at all these different solutions and how you can see them in the graph and which ones you cannot see in the graph. And then, but a clear indication that there were 4, there's just not 4 real ones, there's 4 total altogether. All right, so basically this is what we're going to do. Now, this one was obviously a straightforward one because it was just a little x squared and an x to the 4th. They're not all going to be this straightforward. Okay, that's where the challenging part comes in. Okay, so let's pull it down just a little bit. Let's suppose you had something that looked like a 2x minus the square root of x minus 10 is equal to 0. Okay, now that right at first glance may not look like a quadratic form at all because you've got the square root of x. All right, but what you have to do is you got to stop and think about, okay, well, remember we did that chapter where we had radicals and we went between radical form and exponential form. So we can change the form of this just because they gave it to us in that form doesn't mean we have to work with it in that form. Okay, so if I rewrote this to x and then minus x to the, if we remember square root's got a little 2 there, to the 1/2 power, and then minus 10 equals 0. All right, and then now ask ourselves, is it in quadratic form? Well, there's a little imaginary 1 there. This is 1/2. All right, and that's half of 1. So, all right, we are in quadratic form. Even like this, I mean, it's in what's considered to be quadratic form. All right, so now that I'm good there, I can make a decision. What am I going to let my u be? Okay, well, there's the imaginary 1 coefficient. Don't forget that there. We pick this middle term. All right, so u is going to be x to the 1/2 power. Okay, so let's let u equal x to the 1/2 power. All right, and then again, it forces it to go into a u squared thing. So I keep all my coefficients. I keep the 2. I do a u squared. All right, minus 1. I replace that with u because I said that equals u. Minus 10. Oh, shoot. Equals 0. Oh, why put equals 10 on there? Okay. All right, and again, if I wanted to take this x to the 1/2 power and then square it, this is where I'm getting u squared. I'm taking whatever u is, which is this, and squaring it, then I would get x to the 1st power. Okay, now on this, we usually do slide and divide. So you can do the slide and divide. You don't have to do the slide and divide if you can do the guess and check. Let's go ahead and do a slide and divide. So u squared minus u, slide that, we'd have a minus 20. All right, and then we'll have our u and u. I need a 1 there, so 5 times 4 is 20, so let's use a 5 and a 4. I need a negative on the 5 and a positive here. Then just, if you do slide and divide, just don't forget to do the divide part, because I have a tendency to do that. U plus 2, and then pulling that 2 out in front there, 2u minus 5. All right, so that's just a review from our factoring chapter. All right, now again, set both of these equal to 0. So that one's going to be u is equal to negative 2. This one's going to be, I'm hoping that at this point you can do that in your head. You're going to have a u equal to a 5/2. Okay. Now at that point, all right, what do? We put our x squared back in because we want it in terms of x, not in terms of u. At this point, you're in terms of u. Okay, so we're going to replace u equals x to the 1/2 power. All right, and then I would initially go ahead and leave it to the 1/2 power. So I'm going to replace those u's with x to the 1/2. So let's have an x to the 1/2 power is equal to negative 2. X to the 1/2 power is equal to 5/2. All right, now at that point, you're probably not going to like to solve for x because it's in that 1/2 power. All right, but just like up here, we went from radical form to exponential form. Well, I can go backwards from exponential form to radical form. So I could write this as the square root of x is equal to negative 2. All right, now I can solve these. Square root of x is equal to 5/2. I can easily solve this because inverse operations of square root is squaring. So now I can square this side and I square this side. All right, some of you might have been able to realize I could have squared this. That would have been power raised to a power, 1/2 times 2. I would have got a plain x. All right, it's just harder to see when it's in this form, okay? Square here, square here. So those two things cross out. Let's see, a negative 2 times negative 2 is going to be a 4. And 5/2 squared, don't let me screw up, 25 over 4. Okay, so there's my solutions. Now, something that we didn't do on the first problem, which we should have, because you always should do it. I sometimes have a tendency to forget. All right. The question is, do I happen to have extraneous roots? Do I have to throw one of these out? All right. So you really should be checking. All right. Now, you either check by hand or you check with a calculator, your choice here. Let's do the 4 first, because I think that's going to be easy. All right, so 2 times 4 minus the square root of 4 minus 10. All right, and ask myself, does that equal 0? So that's going to be 8 minus 2 minus 10. All right, well, it's going to be 10 minus 10. Okay, so yeah, this x equals 4 checks. All right, how about the 25/4? All right, that one, I don't know if that's going to check or not. All right, so 2 times 25 fourths minus the square root of 25 fourths minus 10 equals 0. You might want to grab a calculator on this, but then again, maybe not. This is going to be like 25 halves. This will be 5 halves minus 10. All right. This is going to be 20 over 2 minus 10. Am I doing something? I may have done something wrong on something here. And then that looks like 10 minus 10 is going to be equal to 0. So it looks like they both check. So it looks like this checks. All right. However, in my notes, I am saying x equals 4 did not check. Anybody catch a mistake on my first one? X equals 4. This will be, you guys awake or are you all asleep out there? Okay. 2 times 4 minus the square root of 4 minus 10. That's going to be 8 minus 2. You guys are out there letting me screw up here. 8 minus 2 is 6. 6 minus 10 does not equal 0. Well, let's can this. This one does not work. The 5 fourths does work. Okay, so pay attention to that. All right, don't make a silly mistake like I just did, because then you're not going to have the right answer. So out of these two, all right, we're throwing out the x equals 4, and the 25 fourths is the only one that matches. Okay, so definitely make sure you check. Maybe do it on calculator so you're less likely to make a little mistake like that. All right, so I did this example mainly for the purpose of this looking kind of weird, because they're going to give you some that are going to be kind of weird like this. All right, now I think we did a few earlier when we were doing the factoring section, a few where that x term was not a plain x, it was a binomial. All right, so now they're going to revisit that and actually let some more things be binomials under there. Okay, so it's very possible you're going to see something that looks like an x squared minus a 5, that whole quantity squared, all right, plus a 3, x squared minus 5, and then a minus 10. Okay, now, if they let, obviously, hopefully you're seeing this, this is a binomial squared. This is 3 times the same binomial. Okay, so this one is a straightforward one. They're not trying to do anything tricky about it, but this is a binomial instead of a plain x. Okay, so hopefully you're seeing, like when I look at this and then I see this, I kind of see quadratic form right here. I kind of see I've got something, I've got like my, I don't want to use an x here, but I've got a u squared. I've got a 3u because it's the exact same thing there, and then I got a minus 10. All right, so I see that quadratic right there because this and this matches. Okay, since I did do that in u, that doesn't look like a u. Since I did this in terms of u, that tells me what I let u be. All right, my u is going to be this x squared minus 5. All right, and it definitely is in quadratic form. You've got this binomial raised to the second power. You got a binomial raised to the first power. Okay, so it is in that quadratic form. So we're going to let our u be that x squared minus 5. Okay, and then I wrote it right here, but here's my u, so it would be a u squared. I keep that coefficient 3, and I put in the u, and then I do the minus 10. Okay, that's a straightforward factoring problem where I don't have to slide and divide or do anything like that. So I'm going to straightforward factor this one, guess and check. Let's see, that's going to be a 5 and a 2. I need the 3 to be positive, so we'll go plus here and we'll go minus here. Okay, so this is going to be u equals a 2. This is going to be a u equals a negative 5. All right, and then again, you just don't want to forget. I mean, it's really easy to stop right there and say your answers are 2 and negative 5, but you got to remember they're in terms of u. We started in terms of x. So then we want to replace u being the x squared minus 5. Now this time there's a little bit more to it. All right, when I plug this x squared minus 5 in for that, for this first one, I'll have an x squared minus 5 is equal to 2. All right, over here, I'm going to have, plugging it in right there, I'll have an x squared minus 5 equals a negative 5. All right, so just a little bit more work there on solving that. Let's see if I add 5 to both sides. X squared equals 7 plus or minus 7 square root. All right, and then again, let's see, add 5 here. That's going to give me a 0 on that side. I can have 0 there. There's nothing wrong with that. X squared equals 0. You want the 0 there for a placeholder. All right, and then I can take square root of both sides. Square root of 0 is 0. So I'm going to get x equals 0. All right, and then again, all right, this one has 3. Okay, this one has 3 different ones, plus or minus square root of 7 and 0. All right, you should check. All right, I'm pretty sure my online notes I've got that they all work. Okay, so if they all work, then we would have all 3 of them like that. Just doing a real quick check there.
Can I ask a question?
You sure can.
How do we know when to use the plus or minus before?
You mean that plus or minus right there?
Yeah.
That one? Okay, so anytime you're solving for x, if you've got an x squared equals any number over here on this other side, it's when you do the inverse operation, when I do that, that's when I put the plus or minus on both sides. It's like when I'm solving an equation, I am solving my equation right here. All right, whereas, let me try to give it, like, if I just asked you in general to give me the square root of 36, okay, if I wanted the positive principal root, for the most part, we just say 6. Does that help?
Yeah, thank you.
Okay. I was trying to come up with another one because I know why you asked, because like people miss that all the time. They either put the plus or minus when it's not needed, or they forget to put it when it is. All right, but it's in the solving. And then if this was a principal, but it was asking for the principal square root, it'd just be a 6. Okay. All right. So that's with a binomial. We've had the radical in the equation, so you have to go from radical form to exponential form. This one involves a binomial. You're also going to have to deal with negative exponents as well. All right. And then fractional exponents as well. So let's do a negative exponents example. Actually, in this section, they're just trying to throw like as many different types of equations at you just to see if you can solve them and like not panic. All right, they're all in the same form. All right, you just got to not panic and recognize that they're in the same form. So like if I had a 10x to the negative 2, and then a plus 7x to the negative 1, and then a plus 1. Okay, so that negative 2 and the negative 1, all right, I'm in quadratic form. This exponent is half of this exponent. All right, I'm in quadratic form. I cannot factor. I can't do guess and check. I can't slide and divide. I can't do anything with those negative exponents. So I need to put it in quadratic form. I need to use a U substitution to get rid of those negative exponents so I can actually start working with it. All right, because negative exponents there, you can't just like ignore the fact that they're negative. You got to deal with them and get rid of them so that you can work out the problem. Okay, so again, we're going to start. I mean, the pattern on these U substitution ones are the same over and over and over. That's the only good thing about this. All right, so I'm going to find that middle term. All right, that's what I'm going to initially let U be. Okay, so I'm going to go let U equal x to the negative 1. Okay, then everything's going to stay the same just like it always has. I'm going to keep that 10 coefficient. I'm going to keep that 7 coefficient. I'm going to keep the 1, and I'm going to put in U squareds. So I'm going to have I went to red in the last one. Let's switch back and forth. Let's go 10, and then I'll have a U squared. I'll keep the coefficient. I'll replace that with U because that's what it is. All right, and then I keep the 1. Okay, now I have just a plain quadratic. I've got positive exponents. I can do slide and divide on this, and it's going to work. Okay, so I can go ahead and slide here. Let's see, so U squared plus 7U plus 10. We'll go ahead and factor like normal, 5 and 2 looks like. And everything is all pluses because everything's pluses to start with. All right, and then don't forget the divide. Okay, divide by that 10 and divide by that 10. All right, both of those reduce. All right, this reduces to a 1/5. Okay, this reduces to a 1/2. So don't forget to do the reduce. All right, and then pull that 5 back up there. So I'm going to have a 5U plus a 1. Okay, and then pull this 2 up in front. So I'll have a 2u plus a 1. Okay, when I solve, again, I'm going to set this equal to 0. I'm hoping you can do this in your head. It's going to be the opposite of what you see. So you'll have a u equals a negative 1/5. And here I'm going to have u equals a negative 1/2. All right, now from there, it's in terms of u. I don't want to stop. My original problem was in terms of x, so I need to go back and replace again. So I'm going to replace my u with my x to the negative 1. Okay, so I'm going to have an x to the negative 1 is equal to negative 1/5 on that one. And on this one, I'll have an x to the negative 1 is equal to a negative 1/2. All right, now lots of different ways that we can do this. All right, this one probably will be the least friendly. All right, if you caught what I said earlier, which you may not have caught it because I said it and I said it pretty fast. Let's go back and look at this one for just a minute. Okay, let me use another color here. All right, I verbally said, let's take a look at this right down in here. I verbally had said, well, if I had x to the 1/2 power equals a negative 2, all right, I wouldn't have had to have went, excuse me, I would not have had to have went to a square root. I wouldn't have had to switch it back into radical form. All right, if you can look at this and then ask yourself, okay, well, what do I need to multiply that by to make this exponent 1? Because what am I trying to do? I'm trying to solve this equation. I'm trying to get it down to an x to the 1st power. All right, well, what would I multiply that by? Well, I would multiply it by 2. 1/2 times 2 is 1, which gives me an x. Okay, so if you can see that, that's another way to do that, which then would give me 4 right there, which is what we got anyway. All right, now, sometimes if you are good at seeing that, then some people like to go, okay, so I've got an x to the negative 1. All right, well, what power would I raise it to if I wanted to make this a positive 1? Okay, well, negative 1 times negative 1 is 1. So if I raise this to a negative 1 power, okay, then I'd have a 1 on my x. If I raise this to a negative 1 power, okay, then I would have my answer. Okay, so negative 1 times negative 1 gives me an x here. All right, this negative exponent here, I can move it to the bottom, right? So 1 over a negative 1/5, and then I can multiply through by that least common denominator. So x is going to equal to negative 5. All right, now that's one way to do it. Okay, now let's take this one and work it a different way because not everybody can see this. Okay, well, hope I have enough room to do this right here. All right, instead, if you don't see what you have to raise each one of them a power 2, all right, I could take a look at this, you know, and what I did here was I moved it to the bottom and made it positive. I could do that here. Okay, I could rewrite this as a 1 over x. I'm not going to put to the 1st power, but it'd be a 1 over x to the positive 1 is equal to 1/2. All right, all I did was I got rid of that negative exponent because I went from negative exponents, used my laws of exponents, converted it into this. All right, now this is a proportion. I cross multiply down. So negative 1 or negative x, sorry, is equal to 2. Divide both sides by negative 1. X is equal to negative 2. All right, so I did both of those with 2 different processes. All right, this one raising it to the negative 1 power. Okay, this one taking the laws of exponents and converting this into a proportion. All right, either way works. Okay, it just depends on how you like to deal with those negative exponents. All right, again, you should check both of those answers. All right, assuming that I didn't screw up in my online notes, then they both check. Okay, so you plug them back into that original equation. I would probably definitely grab a calculator, plug them back in. Okay. So that one deals with these negative exponents, which you could very well see that. Okay. All right, let's do one more because we've had radicals, we've had negative exponents, we've had binomials as our exponents or as our base there. the last thing that they're going to do is put total 100% fractions everywhere in the problem. Okay, so let's look at one of those. All right, so let's suppose we've got like, I'm going to pull it down just a little bit. Let's go 5x to the 2/3 plus 11x to the 1/3 plus 2 equals 0. All right, I mean, they could just chalk tons of fractions everywhere in the problem. All right, now I do think, at least in the past when we have done a final exam and these type questions have been on the final exam, they were always nice to you in the sense that, you know, this is 2/3 and this is 1/3. So you can real easily see that this is 1/2 of this. Okay. I would assume that if you see any of these in my math lab, they're probably going to be that easy as well. All right. Because like when it's not that easy to see, then it just makes the problem a whole lot harder across the board. Okay. But you first check, make sure it is. All right. 2/3, 1/3. This is 1/2. So I'm good to go. I know that it is in quadratic form. So I'm going to take that middle term and I'm going to look at whatever the exponent is. Okay. And that base, and that's what I'm going to let my u be. So I'm going to let my u be x to the 1/3. All right, now it's going to be a quadratic every time. So again, consistency with the same steps over and over and over. I keep the 5 and the 11 and the 2. All right, that first one's always going to be a, well, left one red. Let's go back to black. It's going to be a 5 u squared. And then keep the 11, replace that with my u there. And then I'll have the 2. Okay. So this first term again, and if you wanted to show it, we could take this x to the 1/3 power and square it, because this would be squaring u, and then I would have the x to the 2/3. So this does all multiply and work out. All right, at this point you do a slide and divide here. So I'd go a u squared plus 11u, slide 5. I'd end up with a 10 down here. Okay, then we're going to guess and check. We'll have a u and a u right there. Let's see. Oh, everything's pluses. It's got to be 10 and 1. All right, everything's got to be pluses. All right, now at that point, you just don't want to forget the divide by part. So I'm going to go ahead and divide by the 5, divide by the 5. This one's already in lowest term, so all I got to do is move the 5 out in front. This one divides out evenly, so that makes that nice. This one turns out to be a 5u plus a 1. This one turns out to be a u plus a 2. Okay, then at this point, let me go ahead and add that. We're going to set both of those equal to 0 then. So this gives us a u equal to a negative 1/5. This one gives us a u equal to a negative 2. Okay, and again, we don't want to stop because things are in terms of u right there. We don't want things to be in terms of u. We want them in terms of x. So we've got to go back and we've got to replace. Okay, so we're going to replace our u equal to x to the 1/3. Okay, so I'm going to replace that u with x to 1/3. So I'm going to have an x to the 1/3 equals a negative 1/5. Okay, do it here. I'll have an x to the 1/3 is equal to a negative 2. All right, and then here again, you have to make a choice. All right, how do I want to solve these? All right, again, if I can figure out what I need to raise this a power to turn this into an x to the first power, I could just do that. All right, we can also take the approach of, well, I'm going to take this x to the 1/3 and then turn it into radical form. That's what we did with the x to the 1/2, like on the very beginning problem. So I'll work both of them out 2 different ways so that you, whichever way you like. All right. All right. I'm trying to solve for x, right? So I want x to the first power. I've got to raise to the 1/3 power. If I then raise it to the 3rd power, okay, 1/3 times 3 is going to give me a 1. So it's going to give me an x on that side. So that's one way that you can do it. That leaves me with an x over here. And then if I raise that to 1/3 power, shoot, it's going to be like a negative 1 over 5 to the 3rd, so like 125. Okay, so that is like really quick if you can figure out what you're supposed to multiply it to the rate, what power you're supposed to raise it to. All right, if that doesn't work for you, you can take this It's x to the 1/3 power. It's a exponential, or it's a fractional exponent. So I can convert to radical form. So I could make this a cube root of x is equal to -2 if I want to just do that from that chapter a couple chapters ago. Now, inverse operations of cube rooting something would be cubing it. All right, so you can clearly see I'm doing the exact same thing to both sides, but it's how you think about it and how you get to it. All right, then of course, cube root and cube is inverse operation, so that all goes away. And then this is a -8. Okay, and again, you would want to go through a check. All right, you definitely want to go through a check, but unless I made a mistake in my online notes, which that's always possible, but I think they do both check. So then my solutions there would be a -1/125 and a -8 for a solution set. Okay, but the thing is, when they start getting when the problems, let's go all the way back up here, when the problems start doing this funky things and all different kind of things, then that means you're going to get some different things down here that you're going to need to solve. Okay, so just don't panic when you get down there. Just think about the math. All right, there's a couple different ways to do it, and it just depends on what you see. Like if you really liked that chapter where we went back and forth between radical form and exponential form, well, then that might be the way to go. All right, but if you can remember that, okay, what am I trying to do here? I'm trying to solve for x. Well, whenever I saw any type of equation, I mean, even if I had something as simple as like x plus 4 equals 10, when I solve for x, that's going to be, we all know that's x equals 6, right? But what is this? That's really just an x to the first power. I'm trying to find what x is. Okay, well, I got to get this to the first power. How am I going to get it to the first power? Well, laws of exponents says I can take something, raise it to another power, means I multiply them. So 1/3 times what is going to give me 1. Okay, so like I said, just a variety of different ways to solve it, and it really depends on each individual person and what you're going to actually see and what you feel comfortable with. All right, but like I said at the beginning, I said this was going to be relatively short. I think this has only been like about 40 minutes. Okay, but